In this video, we're going to be using the net present value method of capital budgeting to decide whether a project should be undertaken or not. In this particular situation, we're dealing with a project that is going to have an initial cost of $60,000. So this $60,000 cost, which is happening now, has a net present value factor of 1. Therefore, the present value of $60,000 now is $60,000. When we initiate this project, we're also going to have to tie up some other working capital. We might need excess cash on hand, we might have to buy more inventory, but the designers of this project who've done extensive research know that we're going to need an additional $100,000 of working capital tied up for this project. So we show that as a negative cash flow of $100,000 now, and so since the present value factor of now is 1, the present value of $100,000 now is $100,000. Both of these are cash outflows because the money is going out. Additionally, we know that in year 4 years from now, we're going to have to spend $5,000 to overhaul this machine. This $5,000 4 years from now has a present value that's much less than that. If we use a present value table, we can go and see that the present value 4 years from now with a 14% factor is 0.592. So if we multiply the 14% factor times the 5,000, we get a present value of $2,960. Where did this 14% come from? There's two different ways to look at it. The 14% is a rate of return that we require on any investment because we feel we can invest this money somewhere else and get a 14% return. It could also be related to the cost of capital, which means we're going to be spending 14% interest with our creditors, or we want a return to the shareholders of 14%, so we're not going to undertake any project that gives us less than that. So we use this 14% factor as a rate of return that is acceptable for our company as a whole. In year 5, we're going to discard this machine, and it's going to have a salvage value of $10,000. We show this as a positive inflow because we're going to get $10,000 5 years from now, while the 14% factor on 5 is 0.519. Multiply that by the 10,000, and in year 5 we're going to have inflows of $51.90. Now, the main reason we're even doing this project is we believe that on an annual basis it's going to increase our cash flows $40,000 every year. Since it's every year, we're going to use the annuity table for a present value, and a 5-year 14% annuity is going to have a factor of 3.433. Multiply the 3.433 times the 40,000, and you'll see that the present value of a $40,000 5-year annuity is $137,320 at 14%. And last but not least, when the project is over, we no longer need to tie up our working capital, so we show the release of the working capital in year 5 as an inflow of $100,000. We show the tie-up of capital at the beginning as an outflow of $100,000. When we release that working capital for other projects, it's like an inflow of $100,000. The difference is that's not going to happen until year 5, so we have to go to our present value tables and see what the present value of 5 at 14% is, and that factor is 0.519. Multiply that by the 100,000, and you have a present value of $51,900. When you add up the 3 outflows and the 3 inflows, you end up with a positive net present value of $31,450. Anytime the net present value is positive or 0, it's a green light for the project. If the net present value is negative, we're not going to launch the project because we're not going to make our 14% return. So this kind of summarizes the capital budgeting decisions that you can make using the net present value method. There are other methods. This is just the net present value method.